All right, let's dive into one of the most powerful and honestly, most misunderstood forces in the entire universe, chance. We're going to start our journey with something as simple as a coin toss. But believe me, we're going to end up questioning the very nature of reality itself. So let's get into it.
You gotta love this quote from the brilliant physicist James Clerk Maxwell. He wasn't just saying probability is useful for, gambling or forecasting the weather. No, he believed it was the true logic of our world. That is a massive claim, and today we're gonna see just how right he might have been.
Okay, so let's just chew on this for a second. What on earth could possibly connect a simple coin flip, the chaotic buzzing swarm of molecules in the air around us, and the bizarre fundamental fabric of reality? They seem like they're from completely different worlds, right?
Well, the answer, hiding right there in plain sight, is probability. But we're not just talking about probability as a simple math tool. We're talking about an idea that starts as a clever way to handle what we don't know and evolves into what looks like a fundamental law of the universe.
So our story begins with probability as something we humans invented. It's a brilliant workaround for all the things we just can't possibly know. Some physicists even call it the calculus of our ignorance.
Think about a coin toss. We say it's 50-50, right? But that's not because the coin is behaving randomly. It's because we are ignorant. We don't know the exact force of the flip, the tiny currents of air, the precise angle of the spin. If we could measure all of that perfectly, we could predict heads or tails every single time. Probability is just the best tool we have when we can't do that.
And really, this is all it is. Probability is just our best educated guess for how often something is going to happen if we do it over and over and over again. It's just a fraction. The number of times we think we'll get what we want, divided by the total number of attempts. It's an incredibly powerful way to make smart bets in a world of unknowns. But here's where things start to get really wild. What happens when we stop looking at just one coin toss, and instead we look at thousands or millions? Well, that's when you discover something amazing. Individual chaos can actually create collective, predictable order.
Check this out. This is real data from 100 different experiments, each one flipping a coin 30 times. Now, you'd expect the most common result to be that perfect 15 heads, 15 tails, right? But nope, it actually happened less often than getting 16 heads. In the short term, things are messy. Reality just fluctuates. And that's not an error. That's just how chance works.
So why do the results always seem to clump around the middle, around the average? It's basically just a numbers game, a kind of geometry of likelihood. As you can see here, if you flip a coin 6 times, there's only one way to get all heads, but there are 20 different ways to get 3 heads and 3 tails. So average outcomes aren't special. They're just way more common because there are so many more paths to get to them.
A fantastic way to picture this is something called the random walk. Imagine a little particle. For every heads, it takes 1 step forward. For every tails, it takes 1 step back. Now, over a long time, its average position is going to be 0, right where it started. But here's the paradox. It almost never actually ends up at 0. It just sort of wanders away.
But get this, even that wandering isn't complete chaos. It follows a surprisingly precise rule. The typical distance that particle drifts away from the start, it's simply the square root of the number of steps it takes. So, out of pure step-by-step randomness, a predictable mathematical pattern just emerges.
And this is the beautiful result. When you zoom out and look at thousands and thousands of tosses, the fraction of heads gets squeezed into this funnel, getting closer and closer to that perfect 50% line. Any single flip is a total mystery, but in the long run, probability becomes almost a certainty. The law of large numbers always wins.
Okay, let's take a breath. We started with probability as just a way to deal with our own ignorance. Then we saw how it brings a strange order to huge chaotic systems. But now, for our final act, we have to ask a truly mind-bending question. What if probability isn't just in our heads? What if it's actually built into the world itself?
To make that leap, we need to shift our thinking just a little bit. So far, we've been dealing with discrete probability, things you can count, like the sides of a die. But now we have to enter the world of continuous probability. This is for things with infinite possibilities, like the exact position of a molecule in this room. The chance of it being at one exact mathematical point is basically 0. So instead, we have to ask, what's the chance of finding it within a certain area? We're going from counting to measuring likelihood.
And this right here, this slide perfectly shows the entire journey we've been on. Phase 1, using probability for a coin toss because our knowledge is incomplete, our ignorance. Phase 2, using it for a jar full of gas because the system is just too complex to track every single particle. And now, Phase 3, using it for subatomic particles because it seems like nature itself is genuinely, fundamentally uncertain.
And this brings us to the ultimate law of the quantum world, Heisenberg's uncertainty principle. It's a cosmic trade-off, a fundamental limit. Think of it like a teeter-totter. The more you pin down one side, say a particle's exact position, the more the other side, its velocity, flies up into total fuzziness. And this isn't because our measuring tools aren't good enough. It's a baked-in feature of reality itself. The consequences of this are just staggering. You know that old solar system model of the atom they taught us in school, with electrons zipping around the nucleus like little planets? Yeah, you can just throw that right out the window. It's a complete myth. The reality is this: a probability cloud. The electron doesn't have a path. It just exists as a haze of possibilities, and all we can ever know is the probability of finding it somewhere in that cloud.
This whole idea was so bizarre, so completely against all common sense, that even Albert Einstein, of all people, couldn't bring himself to accept it. He famously argued against it, insisting that God does not play dice with the universe. He was convinced there had to be some deeper, more predictable reality we just hadn't discovered yet. But here's the thing. For all his genius, every single experiment we have ever run has proven Einstein wrong. The takeaway is just inescapable. The exact same logic we use to make a guess about a coin flip seems to be the fundamental blueprint for atoms, for light, for everything. Chance isn't just a cloak for our ignorance. It seems to be the very foundation of the universe.
And that leaves us with one last, massive, unsettling question. If the universe, at its most fundamental level, is not governed by predictable certainty, but by the roll of the dice, what does that mean for our ideas of cause and effect, of destiny? What does that mean for us? It's a lot to think about. Thanks for joining me on this one.